Okay, hello everyone, and welcome to Handmade Hero, the show where we code a complete game live on Twitch. No libraries, no engine, it's just us and our little typing fingers. We have come to the point in the code where it's time to do a sound mixer. And as I explained yesterday in excruciating detail, sound is kind of a weird beast, but most of the things that we want to do in terms of mixing sound for games are actually fairly simple and straightforward. And so this should not be a terribly challenging endeavor. So what I think we will do today is write a very basic sound mixer to start with and just get that working properly and work out what we would like the interface to that sound mixer to be. And then what we will do probably next week is maybe drop it down into SIMD and make a few concessions to how it works so that we can make sure that we operate properly wide. We don't really have to go nuts optimizing it or anything like this. But just wanted to kind of do a little work there just so we can see if there's any conceits we have to make in the API to make sure that that sort of stuff works smoothly. So we're going to be coding today a bunch of code. So if you would like to follow along at home, it is day 140. Make sure you unpack day 139's source code out of the zip. If you pre-ordered the game on Handmade Hero and downloaded that source file, you want that code to start with, because that is what I am starting with today. Okay, so if you remember where we left off, we had loaded, yesterday was just a day where I explained everything, but the day before that we had loaded sound files, we loaded wave files, and we had it so that we could play back any one of them that we chose. I left it in here where it's playing back, what was I going to say? We left it playing back a piano sample. And one of the things that we have set up right now, which maybe isn't a good idea, but the way that we had our platform code set up is if we miss our frame rate, we get tearing in the audio. So for example, I don't know if you can you hear that? The little like skipping, right? Whereas if if we're running, that's in debug mode, so we don't make our frame rate. If we're running in optimized, we don't get that, right? It's smooth. And again, that's just because we don't actually try to do anything to prevent that sort of stuff from happening. We assume we always hit our frame rate, and we're only outputting as many audio samples as would be necessary to cover that gap, right? So, going from there, let's take a minute to think about what we're doing here. What we want to do, and you can already see that we've, like I said, got one in here where we've got our game output sound here. What we want to do is we want to take this little loop here, which is all it's doing is copying looped the sound that we loaded, the sound samples that we loaded. It's copying those into our sample out area here, right? And what we want to do is take this and convert this to something that can play an arbitrary number of sounds at arbitrary times, and have it all get mixed down in some kind of satisfying way, right? So that we can have as many sounds playing as we want and not have to worry about it, right? So that's our goal. And in order to do that, right, the way we have it set up right now, actually, you can see, is we have a separate call for get sound samples. And the reason that we have a separate call for that is because we thought we may want to call it sort of separately from the way the rest of the stuff in the game state was working. So I don't know if we want to make this something that can be called on separate threads or not. I'm not sure about that. But in order to do that, there were a couple things that we might want to think about in terms of locking and that sort of stuff. So rather than go down that route first, I'm first going to write it just assuming that whenever we produce the sound samples for the game, that is synchronous with the rest of the game. So in other words, the game, other than our background tasks that we have running, like building tiled things and whatever, other than those, we are not calling game get sound samples on a separate thread. It's just running in sync with the game for now. And we might change that in the future. But for now, we're just going to assume that that's true. So what I want to do, first of all, is I want to go ahead and have some idea of what sounds are actually playing, right? So in handmade.h here, in sort of the, this is probably going to be in the game state, I would assume, we want to have some idea of all the sounds that are actually playing at the current time, right? Just something like this. And so probably, I don't know, I mean, there's a lot of different ways that we could represent that. Maybe a linked list is something that seems pretty reasonable, right? We just throw things on the linked list and we just assume that everything in the linked list is playing. We could do that. Another thing we could do is just have an array of a certain number of slots, and we just say that we always play only, the number of sounds that are in the slots. And so if you try to play something and there's, and the slots are full, we just don't play it, some kind of a thing like that. I don't really know. So for starters, I think what I will probably do is I will probably go ahead and make it be linked list based just for the moment, because that seems like the most straightforward thing. So I'm just going to have a thing like playing sound, like so on, and it's just going to have a way to chain itself. And then I'm just going to have a pointer down here that's like, playing sounds, right? That's it. Or I guess I'll call that first playing sound, right? And in this playing sound instruction here, this playing sound link, what I want to do is I want to use essentially the same sort of thing that we use for the renderer for now, which is it's going to keep in it one of those sound IDs, right? You remember we had this concept here of representing things by IDs, and the reason we did that was so that we could have things that got loaded, streamed in and out, and we could still talk about the one that we wanted to talk about, right? So I want to have a particular sound ID, and I want to say that like this is the ID that's playing, okay? And then furthermore, what I need to know is I want to know some information about it. So for example, I might want to know what its volume is, right? I might want to know like a number between 0 and 1 that's like how loud this thing is, 0 being silent and 1 being the full volume that the sound was recorded at originally. Right? So I'll throw that in there. Another thing we might want to do is, since we're stereo, we could technically say that we have like 2 volumes, like a left and a right volume. So this is what what channel it goes into, something like that. That seems reasonable as well. So I want to know that information, and I also need to know, right, if you go and look inside this thing, I need to know where I am in the sound. So as that sound plays over time, I need to know how many samples of the sound I've consumed, so that I know when I'm, writing sound, when I'm sort of gathering sound from that sample, I need to know how many samples I've already played so that I don't play them again, right? When I'm copying these out into the output buffer, I need to know sort of a play cursor inside that sound, if you will, right? So I'm going to say we have another one here, which is like samples consumed or something, right? Or samples played, something like that, okay? And I think that's probably enough to get us started here. I'll go write the loop and see if that makes sense. But that seems like roughly what I want, something where we just have this and we just go through them and we play them as we go, right? Okay. So in this loop, what I would want to do is I would want to say, okay, I've got these playing sounds, right? So here's my playing sound. I'm going to grab out from the game state, whatever the first one of those is. So let me grab out the first playing sound. Go ahead and check that. There we are. And assuming that that's valid, I'm going to go ahead and operate on it. And every time I operate on it, I'm just going to move to the next one in the list. So inside here, we will operate on all of the playing sounds every time we want to produce our sound samples. And, now I think about it too, another thing we might want to do, just thinking about it a little bit more carefully, we might also want to queue things up in terms of samples ahead of time. So we may want to be able to set samples played to like a negative number, right? Where we could kind of say like, okay, we want to delay, we don't want to play this sound for like, half a second or something. I don't know if we really want to allow this. And if we did allow it, I don't know that we want to allow it at this level, but point being, we could allow you to set that to be a negative number so that it essentially waits and then plays it a little bit later on, if that makes sense. Okay. So assuming that we wanted to do it that way, what I then want to do is I want to essentially do exactly this same loop that we're doing here. So for every sample that's in the sample buffer that we're trying to output, I want to go ahead and output the sound. But what I want to do, as you can see in here, we've got our original loop is just copying 16-bit sample data, right, into 16-bit output data. And this is not a particularly attractive option for us here, because if you think about what's going to happen there, as we're accumulating values into there, we might get a lot more clipping than necessary if we were actually to just use 16-bit values as our intermediate buffer. So let me just quickly pop over here and explain this one part. It won't take very long, but let me just give you a little bit idea here, right? So if we are in 16-bit, right? So this is plus 32K, this is minus 32K, right? If we are going to do everything in 16-bit, then if I have two sounds, like the first sound looks like this, right? And then I have another sound that, looks like that, let's say, right? Well, when I add these two sounds together, it's going to clip, because putting this on top of this one, well, this one already clips. Let me draw something a little bit more reasonable. There we go. Putting this on top of this one right there, right, is going to clip. It's going to end up out here. But if I then add a third sound, and that third sound looked like this, right? Adding this sound onto the two of them means that it would bring it back down into range. So actually, I didn't have to clip. Playing these three sounds, I could have played them all together, because this one cancels out some of the effects of these two and brings me back into a representable number. So typically, when you're going to do sound like this, you at least want to do, if you have 16-bit sound, you're going to want to do it in a 32-bit space, right? So what we'll probably do here is just use floats, because that will allow us to also do our modulation, and then our rounding and all that other stuff will work out magically. So what I would want to do is, I think, convert from 16-bit to float, do the mixing, then convert from float back to 16, just at the head and tail end, right? So what I want to do here is say that I've got a sound buffer, right? This is like the real buffer, like so on. And this is probably per channel, right? So I've got, I've got two different channels here, and yeah. I want to be able to write to both of these channels. Maybe I'll actually do this, real channel 0, that'll be something, and real channel 1, right? And we'll set those to something in a minute. So what I want to do is, when I come in here, I want to do essentially the equivalent of what was going on here by stepping through the samples, but this time I want to actually do it in float space, right? So what I want to do is, I want to take the sort of the dest here, right? Dest 0 and dest 1, which are going to be these real channel values, which are the floating point representations of our mixing buffer. And what I want to do is, I want to take each individual sample out of the loaded sound, whatever this sound is, which I guess also I'm going to have to go ahead and actually call here. So let me go ahead and grab out that code. Where is it? It's not load sound, it's get sound. So we don't actually even have one of those yet. So we're going to have to make that as well. So here's loaded sound, get sound, sound ID, sounds ID.value, right? So there we go. So what I want to do here is say, okay, for this playing sound, first I need to get the loaded sound, right? So we'll go ahead and get that. We'll get that from the assets, which I guess is just in, we've got that transient state there. So transient state, trans state equals transient state, oops, transient storage. And the trans state has the assets in it. So all we should have to do is just say, there's the assets we want. The sound ID is whatever the playing sound says that is playing. And then we can just see if we got it back, right? If we didn't get the sound back, then we don't have to worry about outputting, because we don't have the data. So that's fine. And maybe I should put in here as well a couple things. First of all, probably want to actually call load sound on it, right? Probably want to tell it, hey, that sound, I need that sound. You should probably go ahead and fetch it as soon as possible. But the other thing we probably want to do is, we probably want to say, since we missed some samples here, maybe set a volume fade in eventually to prevent it from popping when it actually does happen, right? Or delay it until, oh, you know what, and that's actually an interesting idea. Maybe we just delay the sound till it actually is loaded. And in fact, that's what'll already happen if I just don't increment that. Okay, yeah, you know what, we're just gonna leave it. Because that's what will actually happen. If samples played isn't incrementing, if we just never move it forwards, then we won't miss anything. So that's actually totally fine. Okay, so in loaded sound, we go ahead and get the sound. If we've got it, we go ahead here and start looping through the sample count. And then we need to actually do sort of the actual sum here, right? So what I want to do is I want to sum, like I was saying, sounds just all add together. So what I want to do is I want to sum whatever the sample value is at this particular location in floating point. I want to sum that, and first I want to multiply it, though, before I sum it, by whatever the volume is for this particular channel, right? So I want to go ahead and say, you know, that whatever the volume is, maybe I'll pull those out into temporary so that it's obvious to the compiler what's going on as well. So volume 0, volume 1 will just be playing sound, volume 0, and volume 1. So there you go. And in here, we will just do that summation, right? And so all we really need to do that is to get out whatever the sample value is. And to get out the sample value without worrying about the edge conditions, which we're going to have to worry about in a second, but without worrying about the edge conditions, all we would have to do to get that sample value out is just figure out where in the sound, the loaded sound samples we actually are, right? Okay. So let's see here. What we have in Handmade Asset is right here. So there's our loaded sound samples, 0, sample index, that would grab it out. And of course, we know also that we have an offset, which is samples played, right? So we're going to have to add that in there. So I guess we should also, we should probably account for that as well. In fact, what I probably should do is just say, okay, loop from samples played to samples played plus sample count, something like that. And that way the sample index just is the right index, right? So yeah, and I'll put a little to-do in here for handling stereo. To-do Casey, handle stereo. And we can take care of that in a second. So that's really most of what we're talking about here. We do have to do one other thing, which is that at the beginning, right, we are going to have to clear this out. Because if we're summing into, if our idea is to loop over all the sounds and sum into the destination, then we either have two choices. One, we can special case the first sound and have it just copy instead of sum, which maybe we want to do for performance reasons. But at first, just to get things working, we're going to take a slightly simpler approach, which is just every sound gets handled exactly the same. And in you know, at the very first, at the outset, before we do anything else, we're just going to go ahead and clear those channels, the real 0, real 1 channels. We'll clear those to 0 first, so that our sum will start out at 0 without us having to special case anything in particular, right? Okay, so we're getting there. Now, at the end, we still have to do this loop that we were doing before, right? And what we need to do here is, again, we need to sort of switch things up. We need to switch what our meaning of source and dest is here. So we're writing into the destination. We sum all the sounds. So now we have the sum of all the sounds sitting in these real channel buffers. What we need to now do is loop over those and read out of them to get the actual resulting summed values. And then we need to actually write to the output buffer whatever the actual values are converted to 16-bit, right? So we need to basically, you know, convert these to int16s by taking whatever should be in, you know, whatever we find in that channel and rounding it, right? Something like this. Hopefully that makes some sense, right? Let's do source 1 plus 0.5f. There we go. So now what we're doing is like writing into the left channel. We grab whatever's in the source 0 buffer and we round it, right? because this is going to do a truncation. Then the same thing is true for the right channel, round it. And that's really all we're talking about. Oh, I got to advance these guys as well. There we go. So that's it, and this just down converts. This goes ahead and takes the summed floating point that we have there and turns it into 16-bit output for the channel, which is what we were expecting. Now I'm going to go ahead and get rid of that test sample index because we don't actually need any of this. In fact, we don't need any of that anymore because we're actually trying to replace that with stuff now. Okay. And so now we need to do kind of the rest of the stuff here. And we have, again, we've got some important stuff to do here because this will basically just run out to the end of the sample and then crash, right? So we need to do some stuff that actually bounds the region that we're working over as well, but I'm just writing out the entire routine as an example first. So in the trans state, right, we have the ability to grab memory from the transient arena. So if we want to, we can certainly just do this with temporary memory, which is what we want. So I'm going to go ahead and do that. If you remember, we had a way of doing this. We could basically just say, I need some temporary memory here, so I'm going to do that, right? This is our mixer memory. So I'm just going to say, hey, man, I'm gonna take some memory just for a second from the tran arena, like so. And then I'm gonna end that. I'm gonna use the end temporary memory to give it back just as soon as we're actually done mixing, right? So again, that's basically just a stack allocation kind of a thing, only instead of it coming from the stack, it's just coming from our block of memory in the same sort of way that it would come from a stack, right? So I'm gonna do a push array here to get a channel of reals. And that is going to come again from that tran arena, like so. And when I go ahead and push that on, I'm going to need however many there are for the samples, right, like so. So this is just going to give us those two arrays that we need to work in. So then we go here, we will clear out the mixer channels. Then we go ahead and sum all sounds. And then we have our convert to 16-bit. Very simple, right? So that is actually the entirety of the mixer for the most part. And now we just have to go deal with a few finicky things, right? What we need to deal with, first of all, is the concept that these sounds are finite in duration. So when we come into this loop, right, if you think about what's going to happen, we've got the loaded sound. It has a particular sample count. When this sample index gets past that sample count, when it gets beyond it, we can't read from it anymore or we'd crash, right? Well, we wouldn't crash. We'd read into some other memory because we've kind of allocated these in a block. But we don't want that to happen, right? That's going to start playing garbage into our sound stream. And so while it won't crash, it'll certainly sound awful. And that's, if not as bad, at least pretty bad. So what we want to do here is we want to have some notion of whether or not this sound is at its end or not, right? And so what I want to do is come up with a notion here that's like, maybe something where we talk about the samples to mix, okay? And we'll start out assuming that the number of samples that we want to mix, is however many samples are actually in the output buffer. But we can then say, and I'll also pull this out here, samples remaining in sound, right? Well, how many are remaining in the sound? Well, the number of samples played in the sound is where it's at, and the sample count is the total that it has. So if I subtract those two, I can say, here's how many samples are remaining, right? So then what I can do is say, if the samples to mix is actually greater than the total number of samples that I have, right? Then I want to mix less, right? I want to mix just the number that we actually have, okay? And so when I do that, then this loop here, instead of running over sample count, can just do samples to mix, and that will allow me to avoid any possibility of overrunning the buffer. Now, that does put us into an odd situation, right, obviously, because then we're going to come down here and we're going to say, oh, that playing sound, well, we've got how many samples were played. We're going to advance it, right, by however many we mixed. And now what might happen is we might be at the end of the sound, right? We might have mixed right up to the end of that sound. And if that's the case, then we want to get rid of this sound, right? We want this sound to go away. You know, it's not useful anymore, right? It's not gonna, there's no point in leaving it in the list when it's not actually contributing anything. That would just create our list, you know, make our list just proliferate and just get bigger and bigger and bigger and bigger forever, and that's really not helping anybody, right? So what we want to do here is we want to have a notion that at some point the sound can get killed, and this is that point, right? This is the point where the sound gets killed. And so in order to do that, what I want to be able to do is remove it from the list here and maybe put it onto a free list so that we can just use it again when the time comes, right? When the time comes to play another sound, we'll just reuse that bit of memory. So we'd have something like first free playing sound, right? Something like that. So that would be ideal, right? And so what we'd want to do here is say, oh, okay, when we get down to here, we have playing sound, and it has, you know, a next pointer, right? So the next pointer, if we're going to free the sound, what we want to do is take that first free playing sound that's in the game state. We want that, you know, we just want to basically chain this on here, right? That's the easy way to chain that on. We basically say, okay, now this is the new first free sound, and its next pointer is going to be whatever was in there before. So we're basically just pushing it onto the top of that free list, right? So it'll get recycled. The problem with this is if you notice what's going to happen up here, when we come to the end of our loop and try to go to the next one, playing sound has now been taken out of the list we were trying to iterate. So we can't very well use this anymore, right? We can't use this as a way to get to the next one anymore. So what we actually want to do is we want to snap that next pointer earlier, right? We want to say here that we have a next playing sound, grab what should be the next playing sound, and then when we get to the end of the loop, we use that instead. So that way when it gets overwritten here, it's not a problem. And that's just a very typical thing that you see in a lot of loops where you have to remove stuff from the list you're iterating over. You typically want to do this so that you can protect yourself against the act of having the thing freed screwing up your iteration. Right, so pretty simple, like I said, nothing special there, but just I don't know that we've ever done that on stream before, so I figured I'd point it out. Very common thing to see happen. So there we go. That's what we're looking at here. And for the moment, I'm not actually going to allow those sound delays, but like I said, we left it kind of the possibility open. So I want to go ahead and say that we're going to assert that the samples played is always greater than or equal to 0, so that if we do start doing delays later, we'll remember that we didn't actually write any adjustment code in our mixer to actually handle that. So yeah, that kind of makes sense. We don't want to, yeah, you get the idea. So at this point, we do have some kind of, we do have some issues that we kind of want to address probably, I think. I don't know if it's a good time to start addressing them. But if you take a look at what happens here, we do have a little bit of an arena dichotomy in the game state. We have a world arena, but we haven't really addressed what happens when we have things that want to live outside of the world arena, as sounds probably do. There aren't very many things in the permanent game state that probably do want to live outside of the world arena, but there are some, right? And they're things that may persist across the creation or deletion of a world, and although it sounds weird, sounds are that kind of thing. So for example, if music is playing, when the player goes quit to main menu or something, you don't want those sounds to go away just because the world that was being played goes away. And so the world that's being played and the sounds are not really, they're not really linked in that way. But we don't really have to deal with that yet. I'm just, we can sort of avoid it for now because it's not really the topic stream. But at some point, what we do want to do is start thinking about these things in terms of having split that up, as something like world arena, and sort of meta arena, right? Kind of the things that get allocated, which are going to just be flushed whenever the world gets destroyed, versus things that are kind of semi-permanent. They exist across worlds. And like I said, there's not a whole lot of them, but one example is sound. and there's probably, you know, some other example somewhere that we will hit. There's just not a lot of them, but they're, you know, it's not zero is the point. Okay. So what we want to do now is we want to go ahead and actually create this list here. I don't actually know if we want to do one other thing first, which is that I don't know that we actually implemented the load sound stuff in the asset system. Like, you know, I don't know where we got on that. I don't really remember. So when you call load sound, you know, what actually happens when I call this, right? I call debug load wait. I'm on info file name. Is info file name even ever set anywhere? Would be my first question. Let's see, that's the sound info, right? So sound infos. So I don't think we like we haven't actually done any of this. Is part of the problem, right? Meaning there's sound infos here, and the sound infos are not actually set to anything, right? Am I wrong about this? Correct me if I'm wrong, but I'm pretty sure that that's the way things go. So we had sound infos here, and we're not actually setting them to anything. And so what I would like to do is you know, try to maybe make that be a little bit more concise. So okay. So let's go ahead in here, and maybe we'll say, you know, we've got some sounds coming in here now. So I'll make this bitmaps for now. Note Casey bitmaps, and note Casey sounds. And in here, we're just going to say, okay, we've got some sounds that I had put in there, right, that we had, whatever they were. I don't really remember, so we're just going to look. We had a bloop. We had a drop. We had a glide. We had music. We had pop. These are probably not the ones we will want to use in the final game, to say the least, but you know, that's what's in the directory. You know, that's what's in the directory. It's a nice 30 megabyte sound here. So yeah, so fine. That's what we've got. That's what it'll be. So what I want to do is I want to kind of duplicate the same exact thing that we were doing before, as far as having these assets sound-wise. So we really just want to extend this to you know, sort of talk about sounds now. So we have that bloop that's in there, and there was 0, 1, 2, 3, 4 of those, right? So what we want to do is add, you know, do a thing like add sound asset, where we have those bloops in there. So there's bloop 0, 0 dot wave, and 1, 2, 3, 4. And remember, this, just for people who weren't here when we did all this, this is just entirely temporary code. It's because we have not defined our asset pack file format and directory yet. So we just construct it in code for the time being, but all of this code that you see here will actually just go away, and we will just be loading essentially this data off of the disk. And so what we're doing now is just putting in a little bit of code that sort of simulates what we expect to have. Oops, did I forget crack? I think I did. It's just something that's what we expect to have, so that we can proof it all out and be like, yes, this is what we want. And then when we're ready, I'll go make us a proper pack file that conforms to the format that we have specified here on the stream. And then we can just delete this code and it can go away, right? But until then, we're going to keep doing it by hand here, just so we can, again, not spend a bunch of time making an asset file format and a pipeline and all these sorts of things that actually don't do what we want, right? We want to make sure that it actually does what we want, and not just something that we guess that we might need. Okay, let's see. So pup 0, 0 and pup 1, and this is asset music and asset pup. Okay, so there we go. There's our, there's our assets. And so what we need to do is create the equivalent of add bitmap asset. We need to create the equivalent of that for sound. So in here we need to do something where we say add sound asset. It would not have an alignment, right? So I think, yeah, this just kind of comes in here and does a debug add sound info, I think. And there's really nothing else to it besides that. So there we go. And then when we have that debug add bitmap info, we just need an equivalent of that, which is like debug add sound info. And so the sound info in here is just going to basically be all of this stuff, but with sound replaced in it, right? I think that's literally all there is, and none of that, right? So what we do need to do here is the debug used bitmap count. We need one of those for sound, so we know where we are. Debug used sound, bitmap count. And so we want to set that debug used sound count like so. All right. So yeah, that should be basically everything, I think. Oops, forgot my little ampersands there. There we go. So where are we at? Where are we at here? These sample indexes are uint32s, I guess. Loaded sample count and samples played. This should be uint32 as well. That's a little bit annoying there. I'm not sure we want to do that long term. So anyway, now I believe when we do a load sound, in theory, that should actually happen without issue. So let's go ahead and see if we can make this new system that we've got emulate what we started with at the beginning of the stream, just so we know that we're on the right track before we go ahead then and make a way of adding like a bunch of things to the list. And so what I'm going to do is at the outset, when we first start the game going, where we did that load bitmap now, where we did the load sound before, what I would like to do is actually allocate something that's going to be playing, right? So right now I'm going to put this in the world arena, right? And I'm going to say this is going to be a playing sound. And then I'm going to say that the first playing sound is going to equal that, right? So I'm just basically stuffing first playing sound. I'm stuffing something in there. Again, totally temporary, not going to keep this for anything, but just want to see if our stuff that we just did actually works. I'm going to tell it to play sound ID. Well, I guess I can actually have it be something that actually does the first asset. So in Handmade asset, let's see here, where we do our match asset type and all that stuff, best match asset, all that stuff. So what I would like to do here is I'd like to do maybe that get first bitmap ID and that sort of stuff. How did we... so this is kind of stupid looking at it. We'll take care of that in a second. But so when we do our like get first bitmap ID, we don't really care. The asset doesn't really care whether it's doing a bitmap or not. And so what we kind of want these functions to be able to work whether or not they're using bitmaps or sounds. You know what I mean? And we may want to have a way of asserting that they are the correct things, the correct types that you're asking for or something like that. But I feel like in general, these want to operate on whatever, right? And so I kind of feel like what we actually want here is just things that get back the slot IDs, and then we'll just have little wrapper functions that actually wrap those into the IDs so that you get a little bit more type safety out of it through the rest of the game. But I feel like that's really the better thing to do there, right? So what I want to do here is I want to change this stuff, right? I want to essentially say, okay, we've got a get first bitmap ID, but all get first bitmap ID is like this, get first slot ID, right? Assets type ID. It's literally just a little wrapper. It's just, all it does is wrap that up for you like that, right? And then this is actually get first slot ID and has absolutely nothing to do with bitmaps. It does not care about the bitmaps at all, right? So that's more what I'm thinking, right? Does that make sense? And so similarly, get random asset, you know, that stuff would be exactly the same. It would do, this would be random, this would be get random bitmap from, and this was just kind of an oversight when I was doing it. I just wasn't thinking particularly hard about it when I did it, but now is a good time for us to go ahead and make sure that we don't continue down that path because it was a stupid path. So there we go. So we can do that get random bitmap from, and then this one, oops, and that's, sorry, get random slot from, like so. And I don't know, I feel like this should be get first bitmap from. These names are not really that good either, so that's a little bit better. Get first slot, maybe get for random slot from. That naming looks a little better to me there. And so this will actually, again, we'll do that same exact transformation that we did before, returning just the slot ID directly and not thinking about it too hard beyond that, like so. And so now this is random asset from, and get first slot from, slot from, there we go, first slot from, and then finally we have that best match from, and so we'll again copy that down for bitmaps as well, like so, and there we go, best match asset from, get best match bitmap from. When we call this this asset matching, we just pass in exactly what we have, and that's all there is to it. So then we go get first slot from, we think that's good. Get best match asset from, that will return the slot ID as the other ones did. So there we have it, and done. So now these guys are, wait, what are you complaining about? Identifier not found. Get random slot from. So now these guys are actually get random bitmap from, right? Like that. This is get random bitmap from. This is a syntax error. What we want here is get first sound from, and then we have best match asset. So this is get best match bitmap from, like so. And these are get first bitmap ID is get first bitmap from, right? Okay. So get first sound from now, we need our asset stuff, again, to have all of these same things for sounds. And so the reason I didn't want to duplicate all that code. So all I'm doing here is just changing bitmap to sound in just the wrapper functions, and that way all the rest of the code will work exactly the same way that it did before, right? So, you know, really very simple, nothing particularly fancy going on there. There we go. And so on. This one. And so when we say get first sound from, we need to pass, oh, you know what? I have to wait until we do get the transient state, because that will have the actual assets in it. So we need to actually do that here. So we're going to do get first sound from, and when we do get first sound from, we're going to grab excuse me. We are going to grab that asset ID, the music asset ID, right? Transstate assets. And so that should create our first playing sound. I think I still had the next pointer to fill out there. Game state, first playing sound, next equals 0. And that should be basically it, right? That should create it for us. Let's take a look and see, since we changed a lot of code there, or I should possibly say we added a bunch of code there, I want to go ahead and make sure I can verify that all of this stuff is actually doing what it's supposed to do. So let's go ahead and make sure. I also want to, well, I guess we'll check a little bit later. Anyway, let's take a look in the Tran Arena stuff to see how things are going. Let's go into here. Uh-oh. What is the problem? Access violation writing location. Oh. Oh my. What have we done? How many assets do we actually have, by the way? We've got plenty, right? 17. So what's the problem? There we go. Come in here. Oh, we're still in release mode. Hold on one second. I would like to step through this. Okay. So we allocate the assets. We come in here and set our tag ranges up. That's all good. Oops. Well, I accidentally hit F5. Use sound count is less than sound count. Sound count is 1. Add sound asset. So we just set our count too low. Oh, great. Obviously, that's not going to work. Again, this is all stuff that we really don't have to care about. We just have to make sure that it works well enough for our purposes, because none of this stuff will be set in code. This will all be set in the pack file, because we'll know exactly how many sounds there are in the pack file when we packed it. All right. So let's see if we can look at what I wanted to look at now. So let's take a look at that game state, first playing sound, and see what it got set to. So it's actually got a valid ID, which is good. Hopefully that means we actually located an actual sound slot. The next is null. Our volumes, though, now that I think about it, those should not be 0, because obviously if we want to hear the sound, we would have to give it a sound that is something other than 0. So let's make that full volume for now. And then down in the rest of the code, we can take a look at the mixer now that we know that something is actually going to be given to it. So let's go ahead and come in here. There we go. All right, so we need to load the sound because it hasn't been loaded yet. Eventually. There we go. So in here, we can grab out our volumes, grab out the destination channels, which presumably have been cleared. Let's actually make sure that that's actually true. Yeah. We're going to go in here and see how many samples we're going to mix. We're going to mix the exact number that it told us to mix. Is that what we actually got passed, I wonder? How many samples did we actually get passed? Let's take a look at our sound buffer. 1920. All right. So there's us accumulating into here, grabbing those sample values out and accumulating. Presumably, eventually, the sound actually has some sound in it and it will accumulate. But that looks pretty good. Then we're going to advance the playing sound and keep on going, right? And that should be fine. We're going to go ahead in here and the output buffer. Okay, so that looks reasonable. And so let's put ourselves on something where we can hit our frame rate and then see if that plays back as we might expect. Okay. So now what I might do is just add something that would allow us to trigger those sounds easily, right? And yeah. For the most part, we've pretty much got the mixer all sorted. Okay. So what I want to do now is do a sort of a simple little thing that allows us to spawn a sound, right? And what I want to do when we did our playing sound thing, right, where we were doing these, allocating these playing sounds, what I want to do now is I want to go ahead and move that back up here. Again, like I said, we have the, oh, you know what? We have the sub-arena stuff now. Yeah, it's not worth thinking about. We'll talk about this later. At some point, we have to actually go through and talk about memory a little bit more than we've talked about it so far, because we need to do some actual partitions and or do a dynamic pull from the operating system, one or the other. And I'll probably show how to do both of those actually at some point. But now is not the time for that. What it is the time for, however, is just to assume that we can go ahead and abuse the world arena entirely here and allocate our sounds willy-nilly from it. But what I'm going to do, so what I'm going to do is I'm going to make a to-do for that, and then we'll deal with it a little bit later. So internal void, play sound. Here we go. Okay. So in play sound, what we will do is we will have it take a sound ID that you want to play, right? And it will take also, I guess, the game state that you're trying to play it on. And then it will go ahead and just do exactly what you would think it would do, right? It'll say that we want a new playing sound. It will grab it. It will initialize it the same way that it was being initialized before, right? And it will then put it at the top of the list, right? Oops. And so this is just going to be the sound ID. And I guess at this point too, you know, we could, well, you know, I'm not even going to bother. I'm just going to have this return the playing sound handle, and if people want to mess with the volume afterwards, they can, right? So there we go. That's, you know, us playing the sound. That allows us to play a bunch of sounds, and they'll get added on there. The only thing that I would like to do, what do we got? We got 5 minutes left. The only thing that I would like to do beyond that is I only want to actually do this if I have to. So what I'm going to do here is say this is the first free playing sound. So if there's a free one, use that. If there isn't, right? I guess I'll do it this way. Oh, you know what? No, that's not the way you would do it. The way you would do it if you were smart is you just go, if there isn't a first free playing sound, then you just go ahead and say game state first free playing sound equals the push, right? Push struct, game state first free playing sound next equals 0. That's all you would actually do if you were smart. So then we would do this. And now everything's nicer. Playing sound, playing sound, playing sound, playing sound, playing sound. OK. So what we do here is we say, all right, if there's nothing on the free list, just stick a new one on the free list, right? And set the next one to 0. If there is, then just assume from then on that we do have something on the free list, right? And advance the free list to the next thing, right? So that no one else tries to use this one. And then I think we're done, right? That's all we need to do. Let me go ahead and compile this. Looks good. So what I'll do now is I'll say, all right, when we do the trans state thing now, after we get the asset stuff initialized, now I could do a thing where I just say play sound with this sound in the game state, and that should start our music, right, for us. And it does, so that's good. And then what I want to do is now to test the fact that we can mix things. I'll just go ahead and say that whenever we do that, you know, the hero thing where it launches the sword or whatever, I don't actually know. I don't remember. We had some sort of janky stuff in here that was whatever. Whenever you do this sword stuff, maybe we'll just go ahead and play some sound, right? So we'll play random asset from, right? Get random asset from, sound from. So trans state assets, and our asset is going to be whatever would be something that has a bunch. I think bloop seems good, right? That seems good to me. Play sound does not take 2 arguments. Oh, whoops. Get random sound from asset bloop. How many arguments does it take? That's what I really wanted to know. Ah, the random series. Do we have a random series? I don't actually know if we have a random series to give it. Is the only thing, right? We don't even have one. We haven't really done anything where we want a random series. I guess I gotta stick a random series in here somewhere. Random series, general entropy. So yeah, all right. General entropy. We'll seed that guy. Let's see. Random series, is that not... I don't remember how any of the random code works, to be completely honest with you. Random series, where is it? It's down there. So is it just hasn't been included in here? Where is handmade random actually included? Dare I ask? Let's see. So it's in here. So I just need it to be up in here. Is really all we're saying, right? There we go. So how did we seed? Did we have a way to seed, or did we not have a way to seed? Random seed. That's how we do it. So we need to do random seed, like so. I just need to seed this guy with something for now. The series is now just going to be game state general entropy. And now we should be good to go. All right, so let's see if this works at all. Yep. Oh. Except we have uncovered a bug, I assume, in our removal code there, which is unsurprising. I typed it in rather quickly, and on stream it's a little hard to pay attention to things sometimes. So let's take a look. Did I do everything? Did I do things correctly here in our playing sound when the sound is completed? Playing sound next equals game state first free playing sound. Game state first free sound equals playing sound. I did not. I definitely did not, and I can tell you what I did not do, although maybe I should give people a chance to pause if they want to guess what it is. And that's, well, I'll draw it. So here's our linked list, right? And again, this is the kind of thing, it's hard to always remember these things on the stream. So here's our linked list. And that's why I instantly knew what the bug was as well, because it's something you would probably just know if you were paying attention when you're typing it in and not talking. But point being, here is our linked list. And all I did was take care of this part of it. I didn't take care of the part that actually points to the new guy, right? So here's our sounds. If we're removing this guy's next pointer needs to hop over it, right? So, you know, I need to actually keep track of something like this when we're going through here. That's, you know, going to be, oops, playing sound, sort of the like in pointer, you know, who's ever pointing in here. And that's going to be this guy, right? Because that's where we actually came from, first, first playing sound. Then as we go through, what we actually want to do, and I mean, I guess you can even do it, we can just do it, playing sound could be playing sound pointer, like this, and then just do it this way. So we actually take with us the address of the person who's pointing to us, right? And as long as what's in that address is a valid value, then we're all good, right? Okay. So yeah. So then at that point, we can say that as we come through here, playing sound itself is just going to be playing sound is just going to be playing sound pointer, right? And then the next playing sound, we actually don't want to know what that's going to be necessarily anymore. I mean, we do. But what we need to do when we come down here and actually advance to the new one is we have to advance playing sound pointer, right? And playing sound pointer, we actually need to know what was the pointer that was pointing in to whoever we were, right? So we don't actually need to do this part anymore, if that makes sense, because we're still holding that original pointer. So we don't need to do it quite that way, right? We can get rid of that guy. So what we want to do here when we remove this dude, right, and we say playing sound next, right, we put him on the free list like this, right? Before we do that, we need to make sure that playing sound next is actually what gets put in playing sound pointer, right? So what we want to do here is say, okay, playing sound pointer, right? Playing sound pointer equals playing sound next, so that we can actually have that guy point, you know, the thing that was originally pointing to us is now pointing to the person who is after us, right? And the reason that this is a little bit tricky is because at that point, you wouldn't actually have to do anything to make the list advance, right? That already advances the list, if that makes sense. So at that point, right, you would literally not have to do anything. The only time you have to do something is, and in fact, I guess I could, if I wanted to, I guess I could just put this out here and do it this way. So at the end, right, all I would have to do is either I remove the guy, or I move playing sound pointer to be whatever playing sound's next field is, right? So that's worth stepping through because it's very complicated, and I understand that that's probably a little bit odd, and also I have to step through it because, again, on stream it's a little bit tough. But let me just show you what the idea is here. It actually simplifies the loop a little bit, which is ironic because it's a complicated thing to do, but it actually makes the loop be a little simpler. Anyway, so what we do is, before we were talking about the pointer to the playing sound. Now we're talking about the pointer to a location that points to the playing sound. So we're effectively looking at the slot, like we're looking at the place that holds the pointer. So we start out by taking the address of first playing sound, which is the thing that's pointing to, you know, the first thing we're gonna look at, right? So we come in here and we say, all right, let's go ahead and get the playing sound out of the slot that we're currently looking at, and then everything else proceeds as normal, right? Oops. What happened there? Oh, duh. Loaded sound is not actually a valid thing at this point. So that is not going to work. I take it back. Sound finished. Here we go. Everything look good? Yeah. Sound finished equals false. There we go. Okay. So we come in here, go back to what I was trying to explain, ignoring that part. Oh, and you know what I should probably also do for you is switch to debug build, so you can see me stepping through it in a more sane way. There we go. So in we go. And so now, at the end, if the sound was finished, we'd do some fancy footwork. If it's not, all we're doing is saying, well, okay, previously we were pointing at who, we were remembering who pointed to us, like the pointer that pointed to us, we were remembering it, right? So all we need to do to go forwards is say, all right, whatever the thing is that we're actually talking about then, we just need its next pointer now. That's the pointer that's actually going to be the thing we want to remember, right? So we grab that out, right? Then we come through and we keep going. Now, I want to go ahead and do one so we can see when the sound finishes what happens there. So here's us running, and there's now when we've actually finished. So when a sound actually finishes, what we want to do is say, all right, we were tracking the person who was pointing to us. So now we want them to point to whoever comes after us, right? So we just replace what was ever in that pointer we were tracking with the next person, right? We then say, let's move ourselves to the free list, which is the same as before. And then we continue on, knowing that now the thing that is going to be looked at in this loop is actually already the next person, right? It's already the next person in the list. And so we continue. And then that's it, right? And that's the end of it. There really isn't much else there. At least I don't think so, anyway. Okay. So what is going on here? We have a loaded sound bug, though. Looks like we have a different problem, if I'm not very much in error. Sample index. What is loaded sound? So we have another problem. This time it looks like with the math. Nope. It's not a problem with the math. It's just a problem with our play sound function. Obviously, when we played the sound, I was trying to make sure we set everything, but we didn't actually set everything. Samples played needs to be reset to 0 as well. There we go. All right. All right, so I think we're all good now. Let's take a look here. If I set this back. There we go. Not exactly the sound that you probably want to happen when you shoot in a game, but we're all good now, I think. And so that's really all there is to it. We've got some more stuff that we'd want to do, but that's basically it. And I'm a little over time here, so let's go ahead and go to the Q&A. Yeah. And by the way, so one thing that I will mention here, just in terms of full disclosure. So also, I don't love loops like this that do the singly linked list removal from inside the list. I don't really like writing these by hand because they are a little finicky and hard to understand when you write them that way. So I do usually generate them. I think they work okay. It's just they're kind of hard to understand when you write them. So I do tend to reuse that bit of code. I don't write that by hand normally. Doubly linked lists I often do write by hand, actually. I do generate them, but I actually don't mind writing them by hand, I should say, because they're not finicky like that. Is the sound buffer logarithmic or linear, and do we have to account for that in building the sums for the buffer? So sound buffers are linear in like sound APIs. They're not logarithmic, if that makes sense. All Games Network Video. Do you already have someone composing the soundtrack? Actually, I licensed music for the soundtrack. We may in the future. It depends, like how much money the game makes in terms of like sales amounts. I would like to be able to release the music into like with the game source eventually, possibly into the public domain, but at the very least, release it under copyright. And that's not something I can do with the music that I licensed. So at some point, I may, if the game made enough money, I would try to hire someone to do music that I could include basically as part of the source code as well, right? Because like the art, for example, we have the full rights to, so I can release the art in any way that I want to, whenever I want to, which, we may want to do some of that, right? And so, kind of like the code, where the code's going into the public domain, I may want to release some of the art for people to use as well. Like, for example, maybe we take some of the art and say anyone can use this in any game if they want to, and I don't know what my plans are for that. I just want to make sure we have the option. And so with the music, I don't have the option of doing that because of the license that it's under. So we may try to rectify that in the future so that I can have full ability to control what happens to it afterwards. But I don't have any idea if we'll have money for that or not. A reminder about the parameter order in interlocked increment and the bug it covers up. So is this the Q one? I had been meaning to fix this for a while, and I don't know if this is the one you're talking about. I'm going to go to the one that we're talking about. Interlocked increment, though? Okay, you know what? I don't know what you're talking about. Are we using interlocked increment? Interlocked increment, Q completion count. So I don't know what bug you're referring to, unfortunately. You have to be more specific. I was actually thinking of this one, which is that when we set, when we do the atomic compare exchange in here, I thought there was a thing. Yeah. So the problem is that if we can't begin this task, what we want to do, like if the task begin fails, we want to make sure that we set the asset state back to being unloaded, right? Like that. Because otherwise, it would go to queued, but no task would ever actually get assigned to it because we'd run out, and then it would just never be able to be loaded, right? And so, yeah, that was not obviously something we were talking about today, but it was a bug that we had talked about on the forums and that we needed to fix. And so I did want to put that in there. When mixing a mono sound to stereo, volume of each tuner should be 50% for center panned. Why? Why would that be true? Well, I guess if you want to move it, I see what you're saying, because you want to be able to make it go 100% into the other channel. I'm not sure. Yeah, I guess since they add the sounds add together, I could buy that. I could buy that being a reasonable default, I guess. You know what? I don't know if I don't know. Maybe I buy that. Maybe I don't. Like, it depends whether you want the sound to be full volume when it's in the center, right? So I don't really know if I buy that. I think I might just prefer it to just get quieter as it comes over here, right? So I'm not sure. I'll put a to-do in there for you, but I'm not necessarily sold. Soy Sauce the Kid. Will this audio code allow you to play the same sound simultaneously if you start the same sound before it finishes the first time? So you tell me. You saw me code it. Soy Sauce, tell me whether you think it will or not, and why. TFNW, a reminder about the parameter code, the second and third parameters in the compare and swap. I was thinking of the wrong function, thinking second and third parameters in the compare and swap. You're talking about atomic compare exchange. Yes, I see what you're saying. Did we have them in the wrong order? Let's take a look. Handmade intrinsics. Atomic compare exchange. Expected new. Yes. They're passed the wrong way. How is that working, though? That's... So we just had some... We should probably look into that, though. That seems just like... We must have had another bug. So I wonder if we should try to maintain the same... I'm going to go ahead and do an atomic compare exchange uint32 search here to see where we use it, only in those places. So I'm going to try and keep it the same as Windows, because Windows does it this way, and that way people won't get confused, including myself, because I believe that this is normally the way it goes, right? Let's take a look. Interlocked compare exchange. Exchange and comparend, yeah. So the expected, it goes in the final one. So yeah, so that is how we would expect it to go. We would expect it to go like this, right? We're setting it to queued. We expect it to be unloaded, right? Atomic, setting it to queued, like so. And that's what we expected to have happen. But we must have had some other bug, because why was that ever working, right? In fact, I don't really know. It seems like that shouldn't have worked, right? Because it should never have actually done the exchange. And it should... Oh, but it would always return unloaded, right? So yeah, so that actually would work. It would always return unloaded, because that's always what it would have been, right? So yeah. The audio seems to be frame rate dependent at the moment. Could putting it in a separate thread or using interrupts, if you can, make it not frame rate dependent? Using interrupts would not be super possible on Windows. But you could put it in a separate thread if you wanted. That would help make it not frame rate dependent. Although you would have to do work to ensure that that thread was not starved. So, because there's no guarantee, right, that the operating system is going to actually wake that thread up in time. So yes and no. Really what you want to do usually, and we probably will look at this a little later on, usually what you want to do is, you want to always make your frame rate. But what you can do is you can put more audio into the buffer than is necessary to get to the next frame. And then if you did make your frame rate, you just overwrite what was in the buffer with the new stuff. If you didn't, then you just, go out a little further, and the sound won't actually sound like it's skipping, right? But that's not really super much of a concern at this point. I mean, because we should always hit frame rate, so it's going to be very rare. The shipping game should never miss the frame rate. That's just bad. But if we do want to have some way to guarantee that we don't have a sound glitch, we have other ways that we can take a look at that down the road. Because, sometimes you might miss a single frame once in a while because, Adobe Reader is running in the background and takes some of your time away, or bad things like this. Would you mind adding a sync val compare and swap for GCC Clang? No, I could totally do that, although I don't remember it off the top of my head very well. Do we have another compiler defined in here yet? I don't really remember. There it is. So I also don't know what's the right barrier is, would be the other thing. It's some heinous ASM thing last time I remember. It's like you put in an ASM instruction or something like this. So if you want to tell me what you want there for GCC as well, we could do that. But yeah, I can put that in there. So if it's sync val, compare and swap on LLVM, this is the value. Oh, it's the other way around? Are you saying that it's the other way around for GCC? Anyway, take a look at that and tell me also maybe what you want there if you're trying to compile. Okay, so you're saying ASM volatile. That will do the fence? That looks like what I remember, roughly. I always thought this was kind of a little bit crazy. But yeah. All right, so yeah, I don't know if that helps or not. We can, when I push this code up, and you guys can download it and test it and see what happens, then you'll be able to say whether it actually worked or not. We can fine tune it. No more questions? I'll answer the question now about whether this could play sounds on top of each other. Let's just go ahead and do that by way of demonstration. So instead of playing bloop, let's just play something very loud. Sorry, very long, right? It doesn't sound very good to have this many piano scores playing at once, but as you can see, it totally works. Kind of cacophonic. It's like Philip Glass or something. Robbie, so the reason why it works is because if you take a look at how this thing works down here, right? Playing sound is a totally separate concept from the actual sounds themselves, right? We basically said that we have a separate list of sounds. So, a separate list of playing sounds. So we can create as many entries in that list as we want, and all of them could all point to the same underlying sound buffer, right? So this loop is happening over however many playing sounds there are, not however many loaded sounds there are, right? So we basically have a system where it's completely divided, right? We've got loaded sounds over here, and we've got playing sounds over here, okay? And so if we load in a sound and we have the music in here, we can just go ahead and stack up as many playing sounds as we want that all point to this same piece of music, right? And each one of these, because we partitioned the data properly so that the sample count that had been played so far is in each of these, they can each be at a different position in time, right? And this is a very important thing to understand. You always want to separate your asset data from your instance data, right? This is like an instance of a sound, and this is like the definition of a sound in code terms, right? It's like when we define a struct, and then we have lots of objects that are that type, right? We say like, even the playing sound itself. We define the struct once, that's what's in there, but then we make a bunch of them, right? And the same thing is true for our asset system. We have, a loaded sound that we actually create, but then we can play it as we want to have like records that instance it as many times as we want, so that we can play it, you know, on top of itself or however many times we want and all that sort of thing, right? So hopefully that makes sense. All right, let's close everything down. I don't see any more questions, so I think we're good. Oh, one more. Kuber Caleb, why use a linked list as opposed to another data structure like a vector? The reason to use a linked list here is because we tend to add and remove things randomly. And vectors tend to be... Vectors, you can't add and remove things from randomly without cost. When you add something into a vector, you have to resize the whole thing, potentially, or whenever you get to the end of it, basically, whenever you fill it up, you have to resize it more. And when you remove things out from it, right, you would still have to do the free list tracking. Otherwise, you'd have to compact the whole thing down. So for random removal, in this case, it's much easier to just use the linked list in this case. And part of that reason is because we don't need random access. Like, we never need to say what's the third playing sound, right? And so when we have a situation with random addition and removal, and we don't need to ever do random access, that's a time when a linked list tends to be pretty handy, right? Because that's exactly what it does well. But can you take the output of the sound summer mechanism and play that? Sure, if you wanted to. There's no reason why you couldn't. All right, I'm going to go ahead and call it. It says stream has ended, so I believe the stream has, in fact, ended. All right, everyone, thank you very much for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. It's nice to have sound mixing in there in Zygote form, but it's, you could ship a game with that sound mixer if you really had to. It just doesn't have a few of the features that we probably want to add, like I mentioned on the previous stream, that are pretty basic, and we should probably add them. Anyway, that's what we'll do next week. We'll continue down the sound mixing road just a little bit, just put a few more features in there, maybe make it SIMD as well. So we'll go ahead and do that, and I hope you'll join me for that. Again, that'll probably start Monday. I don't know what time, but check the tweet bot for the schedule. Until then, if you would like to play around with the code yourself at home and experiment and so on, you can always get it by pre-ordering the game at handmadehero.org using the little pre-order button. You can go ahead and check that out. I upload the source code every night after we're done coding here, so you can play around with it. There's also a forum site you can go to ask questions, get ports to Mac and Linux and other good stuff like that. So check that out if you're trying to learn from the stream. It's a good resource. There's also an annotated episode guide on there that's cool. There's the Patreon page if you want to support the video series. And there's also a tweet bot that tweets the schedule to you, as I mentioned before. If you're trying to figure out what the schedule is going to be for the week, check out that tweet bot. It's pretty handy. All right, everyone. That's it for Handmade Hero. I hope you guys have a great weekend. I know I will, because I just got a beta build of a game that I haven't gotten a build of in a long, long time, and I can't say what it is because it's not announced yet, but I'm pretty excited, so I will have a very fun weekend. I don't know if you will, but I hope that you find a game out there to play so that you will too. All right, take it easy, everyone. Hope to see you back here Monday. Until then, have a great weekend, and have fun coding.